Good morning, everybody. We'll just give it another minute or two here to let everyone get settled in, and we'll begin. Okay, it looks like we've got a couple more join, so we'll go ahead and get started. Good morning, everybody. Thanks for joining us this early Thursday morning. It looks like it's going to be a hot day when I'm talking to people from across Ohio. We appreciate you coming. Let me introduce myself. I'm Todd Underwood. I am the Strategic Marketing Manager of SIFT. Just a couple things up front. We will have a Q&A session today. You can put your questions into the chat or Q&A function on your screen, and we'll go through those at the end. Just also wanted to let you know, for some of you who might be your first time here, tell you a little bit about SIFT and what we do. We are the Ohio MEP is a part of a nationwide public-private partnership with centers across all 50 states and Puerto Rico, with a dedicated mission of serving small and medium-sized manufacturers. SIFT itself is one of 6 center affiliates in the state of Ohio. Our vision is to be a partner in solutions and innovation for food manufacturing and agribusiness. We achieve this vision through a unique blend of direct services, a membership consortium made up of leading companies in the food space, and a vast network of resources and other partnerships. Our primary goal is to increase competitiveness and growth in Northwest Ohio and throughout the state. This Agribusiness Forum is something that helps us meet that mission by highlighting trends, new innovations, and more once a month throughout the year when we meet. Today, I'm really excited to introduce our presenter. His name is Aaron Wilson. He's an atmospheric research scientist with the Byrd Polar and Climate Center and climate specialist with the OSU Extension at The Ohio State University. He has a diverse research background, from using state-of-the-art numerical models to solve weather and climate-related questions for the polar regions to applied climatology and climate variability of Ohio and the Midwest. Today, he's going to talk about the evidence that clearly demonstrates our climate is changing, but the changes we experience really depend on our location and where we live. In this presentation, he's going to discuss the observed changes in temperature and precipitation over recent decades, from both the global view and the local view right here in Ohio. So on that note, I'm going to turn it over to Aaron, and looking forward to hearing this presentation. We'll have a little Q&A at the end. Okay, thanks, everybody.
Thank you. Thank you so much. And let's make sure we get the right screen here. Start slideshow. Okay, are we showing up in the correct version?
Yeah, you're looking good to me.
All right. So yes, good morning, and thank you for being here and allowing me to come into your homes and places of business here virtually. I see some familiar faces out there. So Bo and Dale and Larry, hi again. Some of this is probably quite familiar to you, but a lot of new names on the list as well. And so hopefully providing some information that you can really utilize here when it comes to agriculture in Ohio from a climate perspective. So we'll talk about climate impacts of varying degrees. Certainly, a lot of impacts taking place right here locally, a lot of changes that we've seen over the last, say, 30 to 50, even 100 years. And that's certainly going to impact farming and agriculture as we continue into the future. So I always like to start and base us in somewhat of a participatory manner, at least to the best that we can virtually here. But weather is something that we experience all the time. It's around us all the time. It's always happening. And I think the important thing is to remember that we experience weather, obviously, with all of our senses. And so if I shoot a figure like this up here on the screen, this is in Auglaize County a summer or two ago. You can start to feel and sense what the weather is like here. It looks warm, right? The corn's starting to get chest high or so. It's probably starting to get a little bit humid. We can see that by the puffy cumulus clouds that are starting to develop. We experience weather this way. It's continuous. We're always impacted by it. It really unites us all together. Now, as meteorologists, we take a lot of data. We put it on forecast maps and we symbolize different weather phenomenon and then how it's going to move and affect us here in the future. Sometimes we do a good job with forecasts, sometimes we don't, but that's just the nature of the business here. We are collecting a lot of data. Again, weather is a continuous phenomenon. So temperatures, moisture, wind speed, we're continuously collecting this data, and then we can analyze that data. And the important thing, I think, to really close that loop is to then interpret or help folks interpret that data for their use. Water usage, impacts on drought. When do I plant? How much water am I going to need this season? What are my growing degree days, and where are my crops? In terms of their production cycle. And so interpreting that data is really important here. And that's what we want to do. Now, again, weather is always happening. It's in constant motion. And what we can do is we can look at a series of images, satellite images stitched together here in kind of a model form, looking at sea salt, dust, and smoke and how it moves across the surface of the earth. And right away, you start to see certain patterns develop. So the beige is the dust moving off Africa, moving toward the east in the tropical regions. We see this was Harvey, a tropical system that came ashore in Beaumont, Port Arthur, and dropped 65 inches of rain in 4 days there. So there's something about the tropical systems that are increasing, and we'll talk about that in a second. But overall, you see across Ohio here, and across much of North America, the wildfire smoke obviously doesn't sit still. It moves from west to east, and that's really depicting our main weather pattern. So these long, all of this continual motion can be kind of summarized into these long-term weather patterns. And so the weather patterns are really what give us our expected weather over a longer period of time. And that's really what we're doing when we talk about climate. So for this animation, if we're zoomed in, it's kind of hard to see the pattern here. And I like to use this animation in almost every talk because I think it really drives home this relationship between weather and climate. Now, if you're out walking your dog is obviously meandering back and forth, driven by some natural factors, right? The thirst, hunger, needing fire hydrant, different things like that. Now that dog could be moving in the opposite direction of the dog walker at any given point. But if you look at the path that the dog walker's taken, those blue footsteps, that really defines the mean or average path of the dog. So even though that dog meanders back and forth, generally, on average, the dog is also moving in that same path that the dog walker's taken. So we look at these like weather and climate, the dog being the weather, the climate being like the dog walker. And even though we get these ups and downs and these extremes in terms of the dog moving back and forth, or in our daily weather, for instance, we can look at that average pattern that the dog walker is taking. I think that can be really, really effective illustration of these two. So a little bit of, we're not in person, and so I'm not asking folks to necessarily chime in here, but just take a second and think, has 2022 so far, through the first 4.5 months here, have we been warmer or cooler than average? So thinking about that to yourselves, the answer is we've been a bit on the cool side this month, the first 4 months or so of the year. So this is actually for a 127-year record. We're close to the middle here. It's about the 63rd coolest January through April on record. Our records here in Ohio, and our confidence goes back to 1895. So 127-year record. We're about the 63rd coolest start in that record. And what the maps are showing you here are where much of Ohio is close to that average. The gray shading is close to average, with some counties that are cooler than average. And, up in the Toledo area, for instance, cooler than average temperatures by about a degree or so over that 4-month period. And again, depending on where you live, you're going to have a different feel for what this season has been like. But let's zoom into a specific location like Toledo, and let's look at the daily highs and lows for this entire year. So the gray bars that you're seeing are the high and low, so the range of the daily temperature. The dark red on top is the record high for that date, and the blue is the record low. And I believe this is at the Metcalf. So if you're looking at the ranges here, obviously there's a lot of variability. There's that dog walking back and forth quite a bit. So if we go back to late January, we had some pretty chilly weather there late January, close to the record lows, for instance, that first blue circle on the bottom left. March was a particularly warm March. So we had a lot of warmth in March, followed by a particularly cold April. So even though it's been close to or slightly below average, we've had a lot of variability. And even in the last couple of weeks, we went from lows in the upper teens. A few days later, we were in the 80s. A couple days later, we're back in the 20s. And of course, last week, we had a really first big stretch of persistent warm weather with Toledo's record high of 88, eclipsing the old record high there as well. So a lot of ups and downs are part of that climate look that I showed you before versus this weather look. Now we can do the same thing for our moisture. So has 2022 been wetter or drier than average so far? I'll give you a second to think about that. And again, depending on where you're calling in from today, the story will differ. So generally we've seen anywhere from about 7.5 inches of precipitation across the Toledo area, upwards of already 20 inches if we head down in parts of southeastern Ohio. And so in the middle, this is the departure from average being a 30-year window of 1991 to 2020. And we can see around the Toledo region, we're about 1 to 3, 1 to 4 inches below average for the season, the year so far. While we go down from Dayton, stretching through Columbus to Canton and parts of eastern Ohio, we're well above average. We're 5, 6, 7 inches above average for the season. So it can vary quite differently across the state. Now, on a whole, it's the 45th wettest January on record, but that wouldn't seem like that if you were sitting in Toledo, for instance. Now, thankfully, that area has had an opportunity to dry out, and I'll show you, after last fall's extremes as well. So we tend to get hit by these extremes and they move about, but certainly it depends on where you are, and I think that's really important. So again, let's zoom into a place like Dayton, Ohio. So we know it's been drier than average across Toledo, but what about Dayton, Ohio? This is the daily rainfall so far for the year for Dayton, Ohio. And right off the bat, you can see we've got 6 days already in Dayton where we've seen more than 1 inch of rainfall in a single day. As a matter of fact, that March 7th was 2.48 inches of daily rainfall. So we've had just over 17 inches of rain or precipitation so far in Dayton. 50% of that has come down in just 6 days. So extreme weather, very precipitation events, and that's really going to be the theme as we start getting more into the climate side of things as well. So I'm driving home the fact that things change and we experience these things on a high degree of variability. Let's think about spring. So here we are sitting in spring of 2022. It was very cold and damp in April. We had 22 days of rainfall in some locations, yet we still had about 50% of normal precip. And so even though we had less than normal rainfall, we had more than an average number of wet days, and that kept a lot of farmers out of the field. But think back to 2019. I got a lot of questions this season about, is this going to be 2019 when we had so much rainfall across west central and northwest Ohio that we weren't able to plant that season, right? Versus a season like last year, which was the 34th driest spring on record, going back to 1895. And so just our seasons vary quite a bit from year to year, and that's that dog meandering back and forth. And of course, last year, the dry conditions allowed us to get off to a really fast start, and overall, much of Ohio had a pretty decent season. I mentioned the fall extremes, and I'm going to do this because of one impact we had in particular last year. But this was last fall extremes, right? So heading into fall, very warm temperatures. A lot of our overnight lows were near our normal daytime highs. And a lot of rainfall across Northwest. And this is what I was talking about in terms of, it's been dry so far in 2022, but that, there's still plenty of moisture there from the preceding season there across Northwest Ohio. And then think back to December as we got winter started here, just high degree of warmth across the state, 8, 9 degrees above average for the month, plenty of rainfall, and all of the Christmas Day highs that were certainly in the top 10, and the warmest Christmas Day a high of 69 degrees there in Cincinnati, Ohio. And those go back to the 1870s. So very, very warm conditions there on our Christmas. So we experience these extremes. Certainly we're seeing a larger number, more frequent extremes, and that's really the name of the game here in Ohio. So, how did the weather of 2021 impact you and your operations, or if you're farming or others? Certainly from an agricultural perspective, the surprise of last year was the fall armyworm, and that's what you're looking at here. This is a tropical species that does come to Ohio, but just the sheer numbers that we had last year due to the very warm temperatures, multiple generations of these pests were out there, and of course feeding on our alfalfa and turf grass and other things as well. So again, thinking about these impacts, it matters. So whether you're in Toledo or Steubenville or Pickaway County, those conditions are going to impact you on a day-to-day basis. And that's what we talk about when we talk about the weather. Climate gives us that more broad overview, okay? So let's zoom out then and think about this broad overview a little bit. Think about mechanisms that are happening and the connections between what's happening globally and what's happening in Ohio. So 2021 is the 6th warmest year on record since 1880. So we have a robust temperature record across the globe going back to 1880. And if you look at all of the years and rank them, 2021 is the 6th warmest. The top 10 warmest years in that record have all occurred since 2005, and the last 7 are the 7 warmest years. So if you're joining us and you were born after February of 1985, you've never experienced a cooler than average month for the planet. So since the Reagan administration, we've not had a cooler than average month for the planet. Now, again, there are areas that are cooler than average or warmer than average, and that's what the animation is showing you. But overall, as we've headed through the 70s, 80s, 90s, and 2000s, much more of the area of the Earth covered by warmer temperatures, especially in the Arctic. And that sets off different feedback mechanisms as well that we'll talk about. A lot of our climate forcing is naturally driven. It's controlled by the amount of solar radiation that's received on the surface of the Earth. And so we've got these 3 crazy things that we're doing in space. We're going around in ovals versus more circular shape around the sun. We have axial precession, so we sort of wobble on our axis, and our axis changes as well. And all of these things set up scenarios and periods of time where we've got less or more solar radiation hitting the surface of the Earth. So if you've got less summer solar radiation hitting the northern hemisphere, you can grow an ice sheet because the snow doesn't melt over the course of the season because it just doesn't get warm enough. And if you combine where we are in terms of these natural forcings, we should be heading toward a cooler state in the atmosphere, but we're not, because our atmosphere, it's really important to think about how our atmosphere warms. So we have these greenhouse gases in the atmosphere, carbon dioxide, water vapor. They keep life habitable on Earth. We have 60-degree temperatures, or our temperatures are 60 degrees warmer than they would be without them. But they don't care about the sunlight. The sunlight just comes through these particles. We absorb energy at the Earth. We give off energy, heat, infrared light. That is how our atmosphere warms. It warms largely from below or by our clouds also absorbing the radiation coming off the surface. And so if you have more greenhouse gases in the atmosphere, then your temperatures have to go up because you're, by definition, raising the kinetic energy of those molecules. And so water vapor, if you think about water vapor, it's the most dominant greenhouse gas, right? But it's very much tied to the temperature. It's a function of temperature. So as temperatures rise, evaporation shrinks, that rate of air evaporating from the surface, from the ocean and land, and putting water vapor in the atmosphere, that extra water, that's a function of temperature. Now that precipitates out in a week or two, right? So there is a constant cycle of that moisture. But again, the ability for the atmosphere to have more water vapor increases as the temperature goes up. And of course, as we burn fossil fuels, we released fossilized sunlight into the atmosphere by burning our fossil fuels. We add CO2 to the atmosphere, more particles absorb the radiation, increases the temperature. That, guess what? That feeds back into the water vapor as well and leads to further warming. So what we think of water vapor in the atmosphere, it's not a forcing of climate change, but it's a feedback mechanism, right? As we get warmer from more carbon, methane, nitrous oxide, other greenhouse gas emissions as well, we increase water vapor, but that absorbs more energy as well. And we know that for every 1 0.8 degree Fahrenheit increase in our temperatures, we increase our extreme precipitation by about 6 to 7.5%. We increase that amount of water vapor. So what we see though is increased evaporation from the surface. That also leads to rapid drying periods as well. So we have farmers talking about 2-3 inch rainfall. Then all of a sudden, 2 or 3 days later, the moisture at the surface is gone as well, because we've got warmer temperatures that are efficient in evaporating that out. And so these two mechanisms are really important, not just the temperature, but the moisture. And that's really important for agriculture here in Ohio. So we know that CO2 is going up. Nowhere in our ice core records, which we can pull out the gas and find out how much CO2 is in the atmosphere. Our warmest periods on Earth are about 280 parts per million CO2. Our coolest periods, when much of Ohio was under a sheet of ice, half a mile, we were about 180 parts per million. We started measuring this with Charles Keeling directly in 1958 at 310 parts per million. And we were at 419 last May. May is when we peak. This year we'll probably be close to 420, 421. So in 60 years, we've gone up, the same amount of CO2 in our atmosphere that these natural cycles I talked about take thousands of years to do. And that's why we think about our emissions a lot. And I think ag has a big role there. Because if you look at greenhouse gases in agricultural role, this is the latest report based on the Environmental Protection Agency from April 2020. So the pie chart that you see, the bulk of our emissions in the United States are through transportation and industry, right? So transportation, thinking about the need for cleaner fuels, moving goods around, driving our economy. That's the bulk of our emissions. Commercial as well, residential heating and cooling. But about 10% of the pie is agriculture here in the United States. Globally, it's around 30%. And so I think it really speaks volumes to what farmers have been doing even over the last 30 to 40 years in terms of those emissions. If we look at the breakdown, right, we think about carbon dioxide, and I paid a lot of attention to that, but we also think about methane, right? Methane emissions. And if you look at methane emissions on the bottom right, this is a large portion of agriculture. Now, this is where all the cow burping jokes come into play. And obviously policy sets off different groups. But it's important for us to look at these things because we know through better feed quality, we can improve enteric fermentation, right? And those gas exchanges. And that's what we've done. We've been improving feed quality. We've been managing our manure better. So I had the opportunity to speak at Waste to Worth right up there at Ottawa just probably a month ago. Folks are really thinking about improvements to manure management, handling that, decreasing, leaching, decreasing nutrient loss, and also methane emissions. And so these are really important goals that ag is really embracing, I think, across Ohio and here in the US. But all of these changes in our atmospheric composition are driving extremes and changes in our extremes. So if you look at the billion-dollar weather and climate-related disasters, last year we had 21 of those. Mostly, if you look out west, these are heat and drought related. If you look across the southeast, these are hurricane dependent, very strong systems, bigger rainfall. And across the Midwest, it's heavy downpours, extreme flooding, right? If you look at Ohio, we're a water-rich area. Even in the middle of drought, we've got more water than most of the West can even think about. And so most of our, excuse me, that time of year with the allergies. Most of our disasters here in Ohio are through a rain-related phase. So this is the face of climate change here in Ohio, largely through the water cycle. Same thing out west, but it's on the dry side. Same thing at the hurricanes, but mostly across the southeast, mostly with those hurricanes and strong rainfall, also tied to the warming conditions. So it's both. And we can look at a couple different ways. I'm going to briefly look at the National Climate Assessment, the last one, that looked at the land surface change across the United States. And we can see the more recent period compared to the early 20th century, much of the United States warmed over that period, especially in winter, but not all. So there are some downward trends across the Southeast that expand more in summer as well. So what's interesting in the summertime, it's not our daytime highs that are warming compared to the early 20th century. Because we have more water vapor in the atmosphere, it's actually leading to warmer overnight lows. our overnight lows don't cool off as efficiently as they do. And then during the day, more water vapor means we're capped at like 92 or 94 versus hitting 100 when we can do that when we have a dry atmosphere. So we see seasonal differences in our temperature changes. We see seasonal differences in our rainfall as well, mostly wetter in the east, drier out west. We're in the midst of the strongest drought in the desert, and not the desert Southwest, but in the Southwest over the last 1,200 years, right? And here in Ohio, we've gone up about 5 to 15%. We've got regional trends in our seasons, and we've got the intensity. And to kind of drive that home a little more, I want to use kind of leverage the last national climate assessment, or sorry, the new switch to new normals. So the National Weather Service uses an operational 30-year window to talk about what our normal high is today, or normal low or amount of precipitation. We've recently switched to 1991 to 2020. Before this year, it was 1981 to 2010. But what we can do is we can take a difference between those two periods. They've got a 20-year overlap. We're basically dropping the 80s and we're adding the 2010s, and then we can look at the changes across the US. And so that's what you're seeing on the left-hand side, the annual mean change by basically dropping the 1980s and adding the 2010s. We've warmed our normals about 0.5 to 1 degree, maybe more in parts of eastern Ohio. And that's what you can see on the screen right there. In terms of our temperature dog walker and versus the dog, that's the time series you see on the right. That's the actual annual temperature for the United States. And you can see we've had warm periods across the United States in the 1930s, very cool period in the United States between the 50s and mid 70s, and then this strong warming since the mid 1970s to where even our coolest days, our coolest years now are still warmer than most of the 20th century, okay? And there's some acclimation taking place, like we're getting used to these warmer conditions on average. So then when we do see average, a lot of times it feels a bit chilly at times. Again, we can take the difference between those two and we can see what that looks like on the left, and we can break this down seasonally. So if we look at, for instance, our seasons by these cardinal months here, January, maximum temperature change. Look at the upper Midwest and in the northern Great Plains. So they've actually cooled there in terms of the January maximum temperature change. April, same thing, even creeping into parts of Northwest Ohio. The cooler spring. Most of us are warmer here in Ohio in the winter, perhaps a little bit cooler trend in April, although it's pretty flat. Similar in July, pretty flat trends there, and then back to warmer conditions in fall. So we see these seasonal differences among our changes as well. And if we look at precip, again, wetter in the east and the north, drier in the west. That's what's happened over the last, say, 40 years. Most of Ohio's driest periods, as you see on the right-hand side, the 30s droughts, the 50s droughts, very extended, drought kind of periods. We don't see those types of droughts now. We've seen this steady increase in the amount of precipitation. So even our driest years are wetter than a lot of our 20th century years. And our droughts are very short-term, very intense, short periods that are punctuated by these heavier rainfall events. And if we again look at the seasonal differences here, we see more January, so more winter precipitation, 10 to 20%, more spring precipitation, up 10 to 20%, flat to even negative trends in July, and then more precipitation, generally speaking, in fall. So I always pose the question that farmers love a wet spring, a dry growing season, and a wet fall. Those are not perfect conditions, right? We know that, but these are the challenges that we're seeing in terms of the changes that are happening here locally. I mentioned the intensity of the rainfall. There's a link here, and I encourage, I'm sure everyone will have access to the slides or a PDF copy, but to explore some of the changes in the National Climate Assessment. Again, we know that we go up about 6 to 7% for every 1.8 degree Fahrenheit change in our temperature. We know our return values, what we used to think in the 60s of a 1 in 100 year flood or precipitation event is now occurring about once every 35 to 40 years. Right, so we're seeing those frequency changes as well. I'm going to skip over this one. We know our heaviest precipitation events are increasing and go to a more local example. So these are all of the precipitation events for Lima, Ohio here greater than 1 inch total counts every 5 years since 1950. Okay, so it's kind of subtle here to see, but we've seen an increase certainly since the 60s into the 70s, 80s, and then since the 90s, especially mid 90s, we've been seeing more of these heavier 2 and 3 inch rainfall events. Another way we can look at this is to flip it around and say, okay, what are the percentage of rainfall events per year that are above 1 inch on a daily time scale, and just use that a percentage to show. So if you're looking at Lima here, the 1950s, we were generally around 25% of our events in a given year were above 1 inch. Now we're at about 35% here in Lima. We can look at a place like Wassee in Ohio in Fulton County, where we went from about 23, 24%, close to 32% of our events now per year are above 1 inch. And this is across the board. We see it in Columbus, Dayton, we see it in Cleveland, we see it in cities in between, in towns in between, just an increase in those heavier rainfall events. So if we look at the last 10, or we look at the top 10 warmest and top 10 wettest years in Ohio, in Ohio's climate history, 9 of the top 10 warmest and 8 of the top 10 wettest have all occurred since 1990, right? So within that new normal period. And so there's no doubt that we're farming in Ohio today under different conditions than we did in the 60s, 70s, and 80s, right? And those are warmer conditions, those are more rainfall, wetter conditions, but those details on the seasonality really matter when it comes to the impacts. Again, we're still seeing droughts. This is as of last year, April 27th of last year, we had moderate drought conditions extending across much of the northern counties here in Ohio. You wouldn't have thought, right? By the time we got to September, October, that we had no signs of drought across this region. So flashiness, we get more flashiness to the drought, more flashiness of the flooding as well. So we have to think about where we're moving, obviously, and where we're heading toward, the conditions we're heading toward, so we can plan, so we can think about how do we build resilience, how do we adapt, what will agriculture, the food industry look like across the entire world, but also here locally in Ohio. So we know, we use models, and no model is perfect. Matter of fact, all models are wrong. Some are useful, which is generally the phrase that is used. But we have medium to high confidence in what our models are showing us, certainly out to mid 21st century. More uncertainty as you get farther out in time. But right now we're looking at a reality here in Ohio of about 3 to 5 degrees Fahrenheit warmer by 2050, 2060 than what we've been used to over the last 30 years. 3 to 5 degrees Fahrenheit warmer on average. Again, we've increased about 1.5 since the early part of the 20th century. And later in our century, toward 2070 to 2099, when our kids and our kids' kids are around, it's 4 to 8 degrees Fahrenheit warmer. So a lot, big changes, and those are big differences. Keeping temperatures to 3 degree on average warmer than 8 degrees in terms of feedbacks and in terms of impacts, that is a huge, huge difference. If we're looking at rainfall or precipitation in general, we've seen a shift in our jet stream that's causing earlier season heavier precipitation, more winter, more spring events. And then we're likely to see also less summer, so less summer rainfall, seasonal water shortages based on the changes in our atmospheric circulation. So wetter, cool seasons, drier during the summer seasons. So even though we can get a lot of rainfall in a year, we could also get intensified drought within the year. So those are not mutually exclusive events. And if we break it down a little bit, yeah, we may not be hitting as many 100-degree highs because we're capped by the water vapor, but we're looking at 20 to 40 more days above 90 degrees, right? So we're doubling our 90-degree days, extending into September, October, November. Not only thinking about the impacts from a negative side, but what are the opportunities there? We'll get to those in a second. Overnight lows over the winter, fewer nights, 25, 30 fewer nights during the winter where we're falling below freezing. Some folks might say, sign me up, right? Maybe I don't take winter vacations elsewhere. I can stick around Ohio. Well, let's think about the impacts for a minute, and we'll get to those as well. Think about pests and disease and things like that. And then much of our rainfall, again, increasing in terms of those 2-inch or 3-inch rainfall events. So more rainfall, but coming down in shorter periods of time and with that seasonal distribution. So I like to use this figure here that's really showing Ohio's climate on the move. We've been on the move, right? And climates are, weather and climate are persistently changing, but our trends are showing us that we're heading toward a mid-Atlantic winter and an Arkansas summer. And all of the trends that you see listed there, these are what we're observing. This is what we're observing already. So if you think about a 2003 Ohio climate, we've already moved into a central Indiana climate that was 2003, right? We've seen increasing double cropping across, northern portions of the state. We see more southern species of insects that are making it into Ohio. So these are I think a good way to encapsulate how we're moving. Now it's up to us to think about group and collectively, based on these, based on this and what the impacts are, how do we then build some resilience to what we're seeing? And that's really, I think, what I've made my life's mission at this point, is being able to communicate the climate, but then turn it around and ask folks, what are we going to do? Based on this information, what can we do collectively or individually that can help thwart some of these or mitigate some of these impacts that we're going to dive into now? So we've seen plenty of images like this across the state of flooded fields. And certainly if you think back to 2019 and everything that happened then as well. But again, we want to weigh the opportunities versus the challenges. Being as objective as possible, I think we are outweighed by challenges at this point, but it really then behooves us to think about how do we transition and make some opportunities here. We look at growing season length. Are there opportunities to grow new crops, expand the way we conduct agriculture? What are some new commodities that might come out of this, and teaming up with businesses to think about some of the innovation side? From livestock, thinking about longer grazing periods, thinking about reduced maintenance costs. There's a trade-off there between maybe less winter costs, but maybe more cooling costs, cooling needs for the summertime, for instance. Are there opportunities to really improve our soil quality, our structure, through carbon sequestration, improvements in organic matter, improved soil health, improved water health? All of these endeavors are obviously underway here in Ohio, and I think it's really important to think about them also from a climate context and look for those win-win situations. But we know that we're being challenged by quite a few things here, and we're going to kind of piece those out just a little bit. So if we think about direct temperature impacts, right? Warmer temperatures mean more heat stress on our livestock, more heat stress on us as well that are in the fields, or our farm labor as well. But if you think about from a dairy perspective, reduced milk yield and quality, lower feed conversion rates, we think about the nutritional needs, nutritional restriction. We think about improved housing to combat some of the heat or shelter as well. Some of the latest estimates show future climate projections will basically cause about $14 to $40 billion in production losses, agricultural production losses by the end of the 21st century here, right? So these are big losses due to direct temperature impacts. Changes in productivity and the quality of forage. It depends on the crops, but productivity may increase with some crops with elevated temperatures, but there's some concerns with changes in protein content, right? The quality of our food is really important, and a lot of conversations taking place around that topic as well. Increasing temperatures means shifts in our growing zones. What can we grow, or what can we no longer grow, because we're shifting growing zones to the north and west, creating unpredictable growing seasons, right? We'll get into fall springs next, but think about those invasives. This picture of a corn earworm, the possibility of corn earworm overwintering across southern counties in Ohio is increasing. And then that allows for more, inundation of pests the following season. Some native and iconic plants. What will we no longer have here in Ohio? In Columbus, I always like to talk about the Buckeye tree because it's moving toward the state up north. Of course, you all across northern Ohio will see a flourish of Buckeye trees likely before heading up into northern or the state up north up in Michigan, of course. But obviously, I've got to tease my Columbus colleagues when talking about that one. Fall springs, the sense that we get warm in February, March, we break dormancy in crops. Think about March of 2012, a lot of apples, a lot of peaches. we lose those to what we call late season freezes, but freezes in early to mid-April are pretty common across Southern Ohio. But we see, where these variability and high variability events early in the season can drive these dormancy breaks. We know that our growing season's growing longer. In fact, much of Ohio, I know for the Midwest, it's about 9 days. For much of Ohio, it's 15 days to almost a month. Portions of Northern Ohio now are seeing a month longer in terms of their growing season between freeze dates. What are the opportunities there? What can we do from an agricultural perspective that might improve profitability for farmers across the state? And of course, precipitation impacts. We see increased damage to our floodplains, infrastructure, transportation, more health risks associated with mold, disease, pollutants, non-point source pollutants. More intense rainfall means more runoff, and I've been asking farmers for a few years, if you knew a week from today, if you knew a year from today, that on this date next year, you're going to see a 5.5-inch rainfall in 1 day or 2 hours, sorry. What would you do to prepare, right? That's a tough question. That's a big challenge, but we're seeing these heavier rainfall events occur. And this is, I think, what we need to be thinking about for sure. When it comes to production and productivity here, we're really losing suitable fieldwork days across Ohio, much of the Midwest as well. But in Ohio, these two lines here on this graph, the blue shows April field loss and the October is in orange. So we've essentially, since the mid-90s, lost 5 suitable fieldwork days for production in the spring, in April, and also in October here. Now, May is a little bit flat. In June, we've actually seen a slight increase of about 1 to 2 days in June. So what are these opportunities that we can take advantage of in terms of these windows? Obviously, it's driving equipment decisions, bigger equipment, but bigger equipment also might mean more compaction and things also. Thinking about impacts of livestock, increased winter rainfall, heavy rainfall events in pastures and paddocks, increasing the soil moisture, foot disease, and the like. We've seen a big trend upward in Ohio. This is for the Corn Belt in general between December and May in terms of precipitation here in that winter time. We've got research here in Ohio State looking at, what are the impact on gestation, and decreasing body weight. So far, it doesn't look like it's impacted fetus weight, but in terms of gestation and heifers and cows, beef heifers and cows, that is something of a concern and some ongoing research here as well. Impacts on our soil. We talked about, some positive things. Increasing CO2 concentration can improve organic matter, can help increase water efficiency, but also loss of soil organic matter through increasing temperatures, or the erosion impacts and nutrient loss there in the increasing rainfall. So again, we're about what do farmers need to do to maintain profitability, right? And also remain environmentally sustainable. And I'm on the look for what can we do to assist farmers, resource managers to make and respond to these decisions. When we start this conversation, I think it's important to know that there's not a single answer, right? There's not a silver bullet. It's not going to work for everybody. Not every solution is going to work because all of our decisions are based on our values, our culture, resources, where we're located, how we're impacted, our goals, our equipment, our economics, our community structure and cohesion. Every landowner is different. And so it's important to address these issues locally. There's a lot of push. There's a big push from the USDA right now to enhance research associated with climate adaptation and sustainable agriculture. There have been some resources out there like this Adaptation Resources for Agricultural Workbook that you can work through individually, thinking about strategies that a lot of what we talked about, the fundamental functions of soil and water, reducing risks to crops and livestock, and different things that you can evaluate. There's other tools, weather ready, climate ready farms that you're going to start to see more of. And hopefully around Ohio, you're also going to start to see more of that as we undertake some of that work. Obviously, the conservation efforts that are ongoing, H2 Ohio and others, what strategies slow the progress of water from fields to streams that we can reduce and you can't keep the nutrients on the field with a 3-inch rainfall in an hour. What can we do then to really slow the progress? What strategies help build that quality of soil? I think these are all Again, these are not answers. These are prompts and conversations in ways that amongst ourselves and peer to peer, we can talk about how to build and think about resilience in this framework. Again, I mentioned improving soil quality. We know we have an opportunity to sequester quite a bit of carbon if we did everything perfectly in our soils. We know that we're not going to exactly do that, but the more we do, the more we can sequester. Sequestering carbon is not the only answer. We've got to mitigate the emissions side as well. We can't get there just through sequestration. We have to think about more efficient fuels and how do we lower the actual emissions side of our carbon, methane, and others as well. A lot of research going into hybrids and greater heat tolerance for different species and adapting, horticulturally. What can we do? What crops can we grow? Irrigation management's big. I've talked a lot about with folks about dam and catchments to cope with the projected rainfall and evaporation rates. How can we store and harvest water as a crop during those really wet seasons early, and then utilize that water more efficiently during the growing season? And again, that improved irrigation efficiency, are we likely to see more bump up in irrigation use across Ohio? I think that's a question that's posed to the industry as we move forward. I mentioned earlier a lot about livestock and climate change. I think the United States and the world have a big opportunity here to become more efficient in the practices. We've done a lot, but 14.5% of our anthropogenic emissions come from somewhere in the livestock supply chain. So just becoming better stewards and better management of that manure and the livestock, the feed quality, and then demonstrating that to other countries around the world, I think is an opportunity perhaps for those that are interested in doing that. Grants and aid, right? We know grants and aid coming down the pipe here. The disaster relief announcement for 2020 and 2021 crops recently, where USDA is going to provide $6 billion to those hit by those natural disasters in 2020 and 2021. The cost of these disasters are going up, right? And so that's another imperative for us to think about the resilience side. Perhaps you've heard about the Partnering for Climate Smart Commodities call that recently went out. I think phase 1 proposals went in already, phase 2 are soon, but it's about building financial partnerships that can support the production and marketing of climate smart commodities, setting up pilot projects that could be put into place to help farmers and pay farmers to do some of these strategies. We're looking at providing technical and financial assistance to producers that are on voluntarily putting some of these climate smart practices into place. But even defining climate smart, I think that's where we are. Quantifying and monitoring what actually works and what improves conditions is a really important, pivotal, I think, course in our agricultural history right now. There are policy sides from things like the Growing Climate Solutions Act, that are an attempt to get farmers engaged in the research and policy, becoming actors in the solutions. The way we do that is we make these carbon markets more transparent so that we can see who's buying the credits, who's needing the credits, and also the equitable compensation for this work. So there's a lot of work to be done. There's trade-offs there, but this is ongoing and part of our conversation. Some of the latest research, really suggesting that we have already slowed greatly, significantly, our global agricultural production growth just over the last 30 years. And this report here from USDA, I like this. Well, one of the key quotes from there is that if we look at all of our future climate scenarios, right, all of them lower domestic production of corn, soybean, and wheat relative to the future scenario with climate identical to the past 3 decades. So in other words, all of the climate scenarios in comparison to what we've seen over the last 30 years, all project lower production at some point in the future, right? There's some trade-offs depending on crops. So all else being equal, it implies that prices are going to be higher than they otherwise would be, right? And we're already in a hyperinflation, superinflation, high price But that also implies higher premiums and then higher subsidies as well. So big economical, large scale policy economic questions, I think, lie as we continue to grapple with this. And oh, by the way, all of the other external to climate factors that are taking place as well, right? I mentioned inflation, economy, health, pandemic, war, all of these things don't, climate and climate change don't exist within a vacuum. None of these factors exist within a vacuum, and they're really a threat multiplier or complex system of factors that we're having to deal with. So with that, I'll go ahead and end the prepared talk and certainly turn it back over to Todd to get us started with any questions. So thank you very much.
Thank you, Aaron. That was really interesting. Thank you so much. We do have a few questions. The first one that came through is warming will increase the impact of invasive species on land. Are there any predictions for what will happen with the aquatic invasives in the Great Lakes?
Yeah, there is. Trying to think of some aquatic invasive. So one thing that's a little bit unsure, I'll start with not necessarily invasives, but we'll start with HABs first, so the harmful algal blooms. So we know that we deal with these, but as we continue to improve nutrient runoff into the streams and into the lakes, that can have a mitigating impact. So it's a little bit uncertain how those will project out into the future. The latest research, I'm trying to think of some of the things we think about fish species and their impacts from warming lakes. So there will be some changes across the Great Lakes when it comes to those invasive species. It's a bit, as far as the lake, it's a bit outside of my expertise. I'm trying to think of some of the colleagues' work on specific species. What I would suggest, if you don't mind, I know you're anonymous, if you can email me that question so you see my email, I can follow up with you and give you a little bit better answer on this specific aquatic species. I think in general, we expect an increase in different aquatic species, but which ones and how they move is a little bit outside my expertise.
How about for the land? Are there particular species that we're really concerned about as the warming happens?
Yeah, I mentioned the corn earworm. I think that's an important one. More infestation of fall armyworms, more frequent, more extreme events like we had last year. While brought here through transportation mechanisms with the brown marmorated stink bug, for instance, but we see those conditions flourishing and even extending, maybe even perhaps better environments north of here, Minnesota, Wisconsin, Iowa. I'm trying to think of some others. Japanese beetles, obviously, just becoming more of an environment. And again, it's not necessarily, it's a combination of those warmer conditions, more enticing conditions during the growing season, but also in the winter when we have less cold, really extreme cold nights. So we think about the intrusion of ticks, right? This is a big, important and health issue across the Midwest and Ohio, and new species of ticks that we haven't had that give us a variety of other diseases and syndromes. Those are likely to only continue to get worse in terms of projections. That's what we see in Lyme disease incidences on the rise as well. Wetter, more humid conditions lead to more fungus in crops, more disease potential. We talk about wetness, duration. So even though, higher humidities mean we're sitting around with that moisture a lot more, and that, so we can get some of those, think about vomitoxin and some of the things that hit later in the season, depending on that humidity and moisture. Those are all potential as well.
Okay, thank you. Any other questions? I have one that I just thought of during the presentation, and it may sound odd. So when these predictions that are much more high level certainty through 2050, 2060 that you're talking about, we think of it as a graph kind of gradually happening a little more every summer or every winter. Is that really the way it works? Is it a very consistent upward or downward, or is it more in bursts?
So it depends on, kind of a step back about the models. The models themselves, the climate models themselves are, and when we mean scenario, what we're really doing is driving some idea of I guess the best, one of the ways, it's hard to explain in terms of, you might see the term RCP, it means representative concentration pathway. It just means that there are certain scenarios into the future where we basically say, okay, based on humans' ability to mitigate the amount of emissions that we're going to have in our atmosphere, we're going to have a certain warming effect. So whether that effect is 1 degree C, 2 degrees C, or 4 degrees C, we call these global warming levels. I think you're going to see a lot more of that in the coming years as the new National Climate Assessment comes out. But in terms of these scenarios, depending on what the trajectory of our emissions are, do we have a lot of mitigation? We really limit the amount of carbon and methane going into the atmosphere. Then the increase in the temperature is similar for all models out to 2050, but then that's where it starts to diverge.
The divergence.
So I would say over the shorter period, it's sort of this linear, starting to become exponential change. But then depending on where our emissions go from there, it can level off. It can get a little bit higher and then level off, or it can exponentially continue to grow, right? And so when you look at a 4 to 8 degree Fahrenheit warming, that's where the confidence lies. Some individual models, for instance, in Ohio would be much, much warmer. A few models would be, the 2 to 3. We talk about climate sensitivity, which just basically means what's the consensus that our models are really coming to, and it's around 3 degrees Fahrenheit by 2050. That's what we this is what the evidence shows, that we're locked into 2 to 3 degrees Fahrenheit warming by 2050, and then they start to diverge based on those scenarios.
Okay, thank you. That's really fascinating. Okay, any other questions today? All right, everyone. Well, that almost brings us to the end of the time. I really appreciate your time today, Aaron, and everybody who attended. We will be having another forum next month with showcasing some of the new technologies we are implementing at the NOC, both in person and a virtual component. The information for that will be going out today. And again, just thank you very much, Aaron. Appreciate your information. Great information. Everybody have a wonderful day, and looking forward to seeing you guys all next time. Thanks, everybody.
Thank you.